On today's episode, we will be discussing if ML, machine learning, and GP models are one and the same.
The short answer is yes and no. Really, I found kind of those terms are used interchangeably by a lot of people. They'll be like, oh, okay, well, we've got to do machine learning. And you're like, okay, are you talking about GPT or, what are you talking about? So that kind of causes a bit of confusion about their differences. And really, in summary, I guess both fall under the broader umbrella of artificial intelligence. However, they really serve distinct roles. So if we look at GPT models and you think of OpenAI's GPT-4, all the releases, Anthropic's Claude, Google's Gemini, they kind of represent a specific subset of machine learning designed to process and generate human-like language. Whereas if you look at something like traditional machine learning, it really encompasses a wide range of techniques, which are mainly kind of focused on pattern recognition and prediction across various data types. So you're going to see that there's overlap, and again, we'll kind of explore that. So the misconception arises really when these GPT models are viewed as the entirety of machine learning, rather than really one powerful example of its application in natural language processing. I think just by understanding this distinction, it's crucial for kind of accurately grasping how AI innovations like things like Gemini, Claude, they fit into the broader world of machine learning. I think to best articulate the differences, we can look at a few areas, things like the general definition, type of learning, the purpose and output, data and training, usage and applications, and lastly, flexibility. Because I think just doing this exercise, we haven't dealt with all types of machine learning. It's interesting to see the overlap and the differences just by looking at these kind of various areas.
So out of interest, this is my assumption. So machine learning is the practice of creating models using data, transformers, where you need algorithms, which actually creates a model at the end of it. That's the application of machine learning. That's what machine learning is. Your output is always generally a model that you have at the end. And ChatGPT, that model is really just a subset of machine learning, right? It's gone through the same process. ChatGPT is really a model, but it was also built by machine learning. Is that correct?
Well, I think so from my understanding, and again, there's so many different applications, but it's also, I think what we'll touch on is also the pre-training that's different. So, usually you have your training data set, whereas GPT, you really are looking at, this is pre-trained on a certain data set. So let's look at the kind of definitions. I think that touches on those.
Yeah, so it's kind of more the way of traditional usage of machine learning. You do get a model at the end of it, but how that's built compared to how GPT is built, or a model like GPT is built, are very different. Is that kind of where we're going with this?
Exactly. Yeah. And I think, again, those differ in the various sections that we'll look at, because there is the sort of broad definition.
I'm assuming to get even more kind of nerdier and technical, when you get into machine learning, like, are they using specific like neural network patterns and how they're creating it, or fuzzy logic can be considered machine learning because you've got a certain model that you're training for, and like you said, it's a very specific thing that you are training, like fuzzy logic. If you're automatically adjusting like a temperature gauge or whatever, it's not necessarily neural networks, but it's fuzzy logic where it's like you're just trying to get a close enough temperature setting and have it automatically detect and adjust itself.
It is, and that's probably worth saying. So if we look at machine learning and its definition, so it's saying a broad field, and I think that's what's important, is it is very broad, and it all depending on the application. So a broad field within artificial intelligence that focuses on creating systems that can learn from data. That's sort of things like developing algorithms that analyze input data, learn from it, and make decisions or predictions based on that new data. So you can think of things like image classification, to train to identify whether an image is containing a cat or a dog, or fraud detection, like looking through bank transactions and kind of going, okay, these look like fraudulent transactions. So varied, but obviously creating the system that learn from the data. Whereas you've got GPT models or generative pre-trained transformers. So that's a specific subset of machine learning. And that's obviously what we've talked about before, the large language models. And that's using neural network architecture. And that's where obviously the transformer comes in, and they're trained on vast amounts of text data to understand and generate that human-like language. So there's that sort of generating aspect as well.